Yeah, good afternoon, everyone.
Good afternoon, sir.
Good
Good
afternoon, sir.
afternoon. Why so less members? Only 9 members are there in class. Uh, what is the problem? Hmm. Yeah, back here with the IoT class today, and we are going with an activity class today now. As you know that we are almost all end at syllabus and the industrial automation which we are doing, and that's almost all we are coming to end. And the next study is in a commercial building. In that we are going within a phase one and a phase two. So before going to the commercial buildings, actually my intention is like this: we'll go with one particular activity. Why I'm telling this particular thing is the next world, whatever is there, whenever a commercial buildings will be there, what is the role of the electronics or the software company, especially in that particular commercial building, that means in a civil structures. So how we are going to make the commercial building an automated one with an IoT? So this is a one very much important thing which we must know. So that is damn important. So now usually whenever we'll think about a commercial building, the first thing will come with a parking that we had already discussed, and the next thing will come with cameras, security cameras, how it has been installed, and how a fire extinguisher works will be done in that particular commercial building, and how a locking system, everything, identification systems will be there in that particular commercial building. So that we are going to take as another one consideration, and how the eco-friendly is the building, and how greenery we can maintain in that particular building, which will be enhanced with an oxygen supply. So all these terms will come, and future buildings will be commercial buildings would have all these particular things, and automating locking means entering systems, going out security systems, lightning system, automatic lightning system, that home automation what we have discussed, and all based on automatic restrooms. That is another one huge challenge which is there, water consumption, especially in restrooms and all. So all these terms will come in the picture when we will go with especially commercial buildings, that is office foundations or any malls like that, where everything should be taken care with an automatic things. When rather than a manual implementation there, means manpower there, the automatization will work more, and time to time updations will be there in their particular mobiles and all. So based on these things, when I did a survey yesterday, sitting in front of a YouTube or a Google, I find two companies now, the best companies which are making their playoff role in a coming era in a commercial buildings. The one is in a Delta Electronics company, South Korea based company, and another one is a Google. These two companies, they are telling in their own way how they are dealing with an commercial buildings in with their lot of features. How they are going to deal with the commercial buildings, especially they will make the buildings as an IoT based one, starting from power management to all these things what I have told. Now we'll see the videos how the company CEO persons or directors has spoken about, and what is their plan actually about in a commercial buildings and all. And you may see this why I am showing this particular thing. I'll tell you. So now present companies, these are the big companies, the Delta Electronics, you can Google it. It's one of the best top company in electronics, and Google, as you know already. So these companies, how they are making their opening role or dealing in a commercial buildings. So that plays a very much important role, and you must know how these software-oriented companies or electronic-oriented companies are stepping into the civil structures. So that is another one important concept which you should observe. Now I'm having two videos with me. I'll play that particular videos, and if you see that videos clearly, follow up it. Why? Because I'm telling finally questions will be there on that particular video as an assignment. Compulsorily, you have to go through that particular video, and you have to judge how this company is dealing with the commercial buildings and all. Then finally, I've asked you a question like that. What is your opinion based on which company is planning correctly or doing correctly, and which company you are going to prefer? So that type of a question is also there, where you have to answer that particular question. Now, meanwhile, first I will play the one video, the Google company's video. Later on, I will take attendance, and later on, I will play the Delta Electronics video regarding their IoT dealings. I mean, commercial building IoT dealings. Later on, meanwhile, I will pass the link of the assignment to you, and after the first video, I will pass the assignment to you, and you can see that answer that particular assignment questions also. So in this particular, from this particular video, you will feel that. Don't think, see, actually, why I'm trusting on these particular things, especially the AI and IoT based machine learning, and this will be the next life for you and career for you. And the best thing I want to tell you, I think you have observed the news channels and all, that Farishi something who is there, Iran, means the scientist for an atomic energy, he has been killed. How he has been killed yesterday? The Iran has climbed like that. They have been killed by automated machine gun, which has been controlled by the satellite. And the target has been fixed from other country. Imagine from other country how means the machine gun is placed in a truck. No man is there. Through the satellite from other country, they are operating that machine, and the machine will fix the target. You believe or not, I think Kurushi, some name is there for him. So his wife is also sitting in a car just 15 centimeters beside to him, but she doesn't have a single small wound. The target is fixed and shooted only that particular target in a car. And the main important thing here, that is the car is traveling in 100-kilometer speed. So this is things where you must observe as an IoT developers, that how a automated machine gun will fix the target within a span less than that time. How accuracy it is, that moving car of 100 kilometers. So how fast, how accuracy time it should fix the target and identify the target, and it should shoot the target. You can imagine that how the things will be done there. After that, seeing a news and all, even I googled some automated machine guns based on IoT, like that I did. I got a lot of information regarding that. So saying like that, from starting from 3 kilometers to, sorry, span of almost 10 kilometers, they can fix the target. So that is okay. If target is in a static way, not a problem. And I have seen that South Korea has implemented this automated machine guns in throughout its border, and which will be range, can be range around. It can shoot around from 3 to 10 kilometers itself, and it will be automated and it will shoot if the target is fixed. That means already fed the targets will be there, terrorists like that, their pictures, everything will be there. So it will come. So whenever they are coming towards the fence and all, automatically it will shoot. So these type of, I'm not telling like that, means how the automations is coming into the real world. That you have to think like this. In the previous and all, we used to tell IoT yet to come, security based yet to come. So lot of problems is there. IoT is not implemented correctly. All these things we are keep on studying and all, but bit by bit, it's coming to the lives of the human beings. That is, in this incident, you can take as anything that they are telling that America and Israel, they have made this plan, and Israel has made this particular attempt. They are claiming, Iran is claiming that particular thing. So anyway, I'm always thinking about a technical thing. How a dead machine gun, a dead machine gun, yes, which can be operated by the satellite. And my intention is very clear here. Communication with the satellite, it will take minimum time, not so easy. That means it will take a time. But the car is moving around 100 kilometers per hour. So how to fix the target? So how accurate it? What is the calculation? Which algorithm they have used? And how previously the face everything recognition has been fed into the mission. So all like this, lot of questions will arise when we will think in a different way how they have developed that particular mission. Now coming back here within a commercial buildings, just I will share the things. 1 minute. Share the tab. That is correct here. So which one? Just a minute. Just I'll open this. Yeah. Just yes. Yeah. So share the tab back here. How Google is managing the cloud share. Yes. I think, are you able to see this? You have to tell me. Are you able to see this?
So,
Video?
how did we get to where we are?
Hello?
So Google's big.
Hello?
Not really surprised, but we have
Yes, sir, it
hundreds
is
of
visible.
buildings. We have tens of millions
Audio?
of square feet on
Yes, sir, it
all
is
of our
audible.
offices and
So
all
I
of our
can
labs.
mute it?
And we have difficulty managing that, right? So there's existing tools and platforms have difficulty scaling. Data standardization in practice is difficult. So what we've done is we've built tools that allow easy, fast, and accurate commissioning at scale. Because when you think about it, you know, building management today is really fine, right? And the answer is, well, not really. So we built this platform in order to manage our buildings better. And fundamentally, we want to run Google on Google. Right? So we want to be a customer of ourselves so that we can show this is how we manage our data in our buildings. So we want to be able to access our data, we want to be able to analyze it, and we want to be able to act on it. So today we're going to talk about the platform, how we built it, some of the data science behind it, and then we're going to show you a little quick demo of the kind of applications that you can build on it. So today when you're thinking about building management, there's really sort of three personas. Right, the first one is if you're either the landlord or the sole tenant. Right, so you're caring about things at scale. You may not care about an individual building, but you care about how, for example, the energy spend and the space happens at scale and why this building is working better than that building. Right? You may also be the facilities ops manager. That's a little bit more focused. You care about a particular building or a particular campus, and you want to know how you can actually operate it better. You might be dealing with trouble tickets. You might be doing truck rolls in order to do maintenance and so forth, right? And then there's the occupant, right? So all of you here today probably work in an office, and you care about having the building be comfortable. You care about the facilities being able to let you get your work done efficiently, effectively, and comfortably. So what's the opportunity here? Well, so first is energy. That's the first one that anytime someone's talking about smart buildings, they really sort of hone in on, right? You want to be able to use less energy, and you want to spend less on it. And I don't think we really need to go into too much detail about sort of the motivation behind there. It's both on cost, it's on efficiency, it's being more green, right? If you're on the operational side, I don't think it's uncommon to say that people really get alarm fatigue, right? If you have anything to do with operating a building, you know that there are literally tens of thousands of alerts that come in either weekly or monthly that are just routinely ignored. You don't have the time to be able to dig into the ones that you really have to take care of in order to address issues that you have either with occupants or with your facility overall. And they hide efficiencies that you might otherwise be able to realize if you were able to dig deeper. And then on the productivity side, answering hot and cold tickets, that means people are uncomfortable enough not to be able to get their work done, and they're telling you about it if you're managing the facility. And moreover, Google has tons of buildings. Some of them are very complex layouts. People have a lot of meetings, and we have found that people actually spend, and this is a measured amount, millions of hours searching on the floor for the meeting room that they need to get to. Now, there may be the issue that you're having too many meetings. That's a separate discussion. But fundamentally, you need to be able to get people to where they need to go faster. And then there's something that is very important. I'm not going to be able to go into too much about it today, but it's cybersecurity. You want to make sure that the devices that you have, and it's a growing set of them in your building, whether that's HVAC, so climate control, whether it's occupancy sensors, whether it's different kinds of alarms for water, life safety, that kind of thing. All of them are safe, and they're communicating in such a way that they're only communicating the way that they should, and that somebody isn't going to be able to compromise your network through your air conditioner, right? So there's lots of stories that you've heard about that in the news, and we don't want the systems that we're building over here to be one of those vectors. So our platform is really to the rescue. And the nut of it really is we want to have the ability to stop having people be your sensors. Right? You want to be able to use sensors that you have in the building, and you want to gain the intelligence from that, right? So on the energy efficiency side, you want to be able to gather and aggregate all your data. You want to be able to use machine learning, ML, to detect anomalous behavior so that you can address it. On the efficiency side, you want to be able to filter all of those tens of thousands of alarms that you unfortunately aren't able to get to the small number of them that you actually want to dispatch a tech or dispatch a truck to actually take care of. And when you have people who go on site to address these issues, you want them to be better informed. You want them to know where the devices are, what's actually going on, and what could be the root cause of causing them to malfunction. On the occupant side, you want to be able to not wait for the trouble tick to open up. You want to be able to detect that something is sufficiently out of band to be able to proactively address it. And you want to be able to definitively get people to where they want to go, right? So they shouldn't be lost. They shouldn't waste time where you're waiting for that last person to show up for your discussion or your meeting. And then on the security side, we want to be continually monitoring these devices to make sure that they're only communicating in a way and only communicating to the devices that they're supposed to be. And like I said, we can talk more about that afterwards if you're interested in that particular aspect of the presentation. So today's building management systems are really siloed, right? They've been around for a long time, but fundamentally you're going to have for each one of the different silos, whether it's AV or energy or lighting or security, they're going to have their own UI, they're going to have their own stack, their own storage, which may be on-prem, it may be in a third-party cloud, it may be through an API to access the devices. They're going to have their own networking requirements, and they're separate. right? They also tend to be very rule-based. They don't tend to be learning, so it makes it difficult if you get your rules set up just so for one building to be able to take them and put them into another building. It's basically a lot of walled gardens, and that's problematic, right? And today, it's also sometimes difficult to be able to take all of these separate silos and combine them into a more cohesive orthogonal platform where you're able to access things and apply the same kind of intelligence to one system as to another. So what's our approach? This is the platform that we want to build. It really orchestrates all of this together. And it starts with the fact that we want to be able to take any kind of device, like I said, whether it's a climate control, whether it's a sensor, whether it's security, and think about it in sort of a orthogonal way, right? So we want to be able to have an API that your mental model of how you think about all these is the same. So at the bottom you have your devices and your network and your connectivity. So, fundamentally, that's not what we're going to go into. We assume that you're going to have some kind of a gateway, you're going to have some kind of IP connectivity so that you can talk to these devices and communicate with them. And they're going to use, any kind of industry standards, Modbus, BACnet, et cetera, to communicate with you. And we're assuming that you have all of that set up. That's kind of a, standard understood way to do things. But then on top of it, what we're going to do is we're going to take the data from each one of the devices and put it in a data lake. Now, when I say data lake to you, that means a lot of things to different people, but fundamentally to us, it's a time series database stamped for each one of the devices and done in such a way that we understand the ontology, the relationship of the devices to each other, have generalized them to different classes of devices, and we're able to access them in a structured way. Right? Sometimes a data lake can be thought of as just sort of a collection of data, but here, we're putting order on top of it. And we do that using a building ontology and metadata about each one of the devices. And Charbel will go into much more detail about that later. And another thing that we do, which is I think a little bit different than other systems, is we have spatial understanding of where these devices are, where they are in relationship to each other, floor maps for the building, so that not only do we know what the device is, what it's connected to, its relationship to other devices, but where it is as well. And of course, none of this would be useful unless you had APIs in order to access the data. And we do so using the same kind of mental model that you do for all of the other Google Cloud Platform stacks and technologies that we have. This is something that we did because it makes sense to do it in a standardized way so that other developers who are developing apps on top of this are able to access it in the same way that they do any of the other cloud platform technologies. And altogether, this is what we're calling the digital building platform, right? So taken all together, that's sort of the special box that we have, black box, if you will, that takes in the data on one side and provides it to applications on the top. So this is where we built we worked with some third parties to take their existing systems that do things like alarming and analysis and so forth, and they use our platform as the source of their data. Or we also have some groups inside Google that have built first-party applications to do things like anomaly detection and alarming as well. So how do we onboard a building? Now, what does onboarding mean? So onboarding, for anyone who's set up a building automation or a building management system, is taking your devices and being able to talk to them and getting them connected into whatever kind of management software, or platform that you have. And it usually is a very painful process. Sometimes it can take days, sometimes it can take weeks. Well, with the platform that we built, we started there. And it actually did take us on the order of days or weeks to onboard a building, but we actually got it down to the point where we can do it in a matter of hours for most of the buildings in Google, which is a pretty big, impressive thing, right? So we start where you either have greenfield, which are new devices, or brownfield, which are existing devices, and those devices might be individual. So they might be something like, an air handler. They might be something that you think of, sort of in aggregate together, where you have different component devices like a VAV or something like that inside of it, and you think of them as one, right? And then we create an idealized representation of them, right? So you have one where you think of each one of the classes of devices in a way that it encompasses all of the special fields and data points that each one of the manufacturer's devices might have in it, but we do it in such a way that you can address them orthogonally, right? So you don't have to worry about what brand this is, what type this is, and so forth. And so if you've ever dealt with these devices, each one of them has data points. That's a piece of data and a tag that basically says, what is this, what does it represent, what units are it in, and so forth. And in the idealized representation, we have the same thing. And we do this in such a way, again, to make it so that you can treat all of the devices in a particular class the same. And then we need to figure out, for each one of these data points, what semantic tag, what tells you what this data is and what it represents, what unit it has, and so forth. Right? So for example, this might be a tag that you have in the actual device, and here are the different semantic tags that we might break it down into, because we can do clustering and matching to basically say we recognize this kind of device and this set of points that it has, and this is how we map it to a set of tags. And then basically we have a mechanism that will go through and do that matching for all of the other points and tags in the system. And that way, it saves a lot of the manual work that you used to be able to have to do before to do it in a more automatic way. And then, of course, you have the APIs to access it on the top, and then the applications. Right? So in whole, this is basically what the stack looks like after you've gotten something onboarded and into the building system. So what do we do with all this once you're done? It's all great to have the data, but unless you actually make use of it, it's not that interesting. So just as an example, particular problem that you might face is an out of set point temperature. Right? So if you look at the box in yellow, that's what the data looks like raw coming from the device, and it says that this is a sensor that should be in the range from 62 Fahrenheit to 72 Fahrenheit. It's currently 81 degrees, so obviously that's problematic. Right? This is landed in the data lake. The sensor data captured the data and it put it in there. It tagged it with a timestamp. Right? None of this is really unusual if you've dealt with any typical building automation system before, but we also have the ontology and the mapping, which tells you where the device is, what type it is, what kind of class it relates to, and allows us to get more contextual information about this particular error, such that when we then dispatch someone to take care of it, they're able to have more of this context and hopefully are able to address the problem faster than they otherwise would. So the whole is greater the sum of the parts, and you can use all of these kind of sensors together to tell sort of an aggregate story. Now I'm going to switch over to Charbel, who's going to tell you some of the data science behind all of this platform.
Thanks. So I want to talk about how do we make sense of this data. As Mark mentioned before, we have all of these silos that are really in verticals where the data is trapped. So if you take a step back, we have really different devices and systems that are provided by various vendors. And they can vary by geographic region or by country, because no single vendor can cover the whole planet. And as we mentioned, that data is trapped in silos. We have the lighting, we have the cooling, the badge access reader. All of these data are really in vertical. And of course, when we're talking about a building, it's a whole ecosystem. So we need to do data correlation for better management. If we know that a space is not occupied, we don't have to clean it. Or maybe we don't have to cool it. Or maybe we don't have to light it. So all of these simple information can give us a lot of insights to better manage a space. And of course, we want to be able to correlate the data so we can serve it for these three personas, whether you are a landlord, an occupant, or a facility manager. So one of the ways of doing that is by relying on ontology. So before I go through it, by show of hands, who heard about this word before? Okay, cool. So an ontology is a common vocabulary to refer to the concepts in a building, but we can also use it as a way to express relationship between these concepts. Don't frown upon this definition. I will go through more details. So this is something we didn't invent. It started with the Greek philosophers when they started to map the world, how a mammal can relate to a human, how does a living being is related to the planet, and all of that. And of course, computer scientists like to reuse things from the past. So computer scientists reuse ontology as a way to represent information. It can be also in a building. So in a simplified definition, an ontology is just a way to represent domain concepts and the relationship between these concepts. They are usually represented in triplets, and we distinguish between classes and instances. So you can see we have a city and a country, which are classes, connected by is located in, which is a relationship. And then we have the instances like Paris is located in France. What is nice about ontologies is we don't need to invent how do we represent them, because the World Wide Web Consortium already proposed standardization like RDF, OWL, and JSON-LD to represent and express these kind of relationships. So let's take an example in a building. We have a location, which is a concept. We can have subcategories like a building floor and a meeting room that are also connected together. And we can also instantiate them with a room, a floor, and a specific building. So this can be seen as one of the silos. And we also have another silo, which is the devices. We have a sensor that is measuring a quantity, a temperature sensor measuring a temperature, and then we have the instances. So as you can see, thanks to the ontology, we can link these two silos together by adding relationship and connecting them together. So there's a lot of ontologies out there. We didn't want to reinvent the wheel at Google, so we looked at what is out there. I'm going to focus in the following just on 3 of them. And as you can see with the cloud tags, there's really a lot, like Sarif, and KNX, M2M ontology. I'm going to focus only on 3 of them. So the Haystack Vocabulary started in 2014, and it was one of the first efforts that said, okay, I'm going to start proposing a vocabulary for my building domain. And this is where we started to see these tags emerging. So it's a tag-based system, similar to the Twitter hashtag, where for a certain point, like a temperature sensor 1, you can assign one or many tags together. So it's a tag-based model, it's not an ontology. And back in 2014, they didn't rely on W3C consortium, but they had their own Zinc standard. Another interesting progress was provided by Siemens in 2015, which points out in a research paper the limitation of Haystack. The lack of expressivity, the ambiguity in assigning tags. You can imagine that you cannot express relationship with just tags. It becomes really very hard to manage. And of course, you need an abstraction when you do queries. The tags are a very flat system. When you are trying to query, you might want to query by location or by an upper class. So you lose that with the tags because they are flat. So Siemens proposed the Haystack Tag in ontology, which proposes to mix between the Haystack tags, the semantic sensor network ontology, and the building models like BIM and IFC. So basically what Siemens tried to do is to take these flat tags and represent it into triples. But as you can see, it's not really a lot of explicit relationship just to add has tag in the triplets. We still lack of expressivity. And this is where bricks come into the picture. So the brick schema proposed by IBM and several academic universities, which took into consideration Haystack, Haystack tagging ontology, and Sarif, and proposed a model that is, I would say, richer than just a simple tag model. And it's also relied on a pragmatic approach. They took around 6 buildings that are scattered across the globe, that they supported different vendors, and they tried to refine what are the concept or the common concepts of these ontologies, and they proposed Brick. What is nice about Brick is that it's not just out there, it is part now of the ASHRAE body to propose, which trying to push Brick to become a standard. So this is really an interesting thing for if you are in the buildings domain, because you can go and influence this vocabulary and this ontology. And of course, Brick schema guided our choice for our digital building platform because of its richness and that it builds on prior work related to the ontology. So now that I talked about how do we represent information, I would like to talk about what are the bricks that we used that we reused from GCP to build this platform. So we have a cloud IoT to connect the devices to the cloud. We have PubSub, which is a publish subscribe mechanism. We have Dataflow for batch and streaming processing, and Bigtable and Spanner for storage. And then I'm going to show a little bit a simple chatbot that we built in a very quick manner to show how easy it is once you have the ontology and these APIs in place, how easy it is to tap into the system and extract whatever information you would like to have. So first I'm going to talk about about Iot Core. It's a fully managed service for you to connect your devices and systems to the cloud. And as you can see on the architecture diagram, you can combine it with different other components like PubSub, Dataflow, so you can collect, process, and analyze your data. So far in the Bay Area, we have around 100 buildings that were onboarded, and we have around 20,000 devices that are connected, along with 120,000 points that are publishing data to the cloud. So once these devices are connected and are pushing telemetry data to the cloud, we rely on PubSub, which is an enterprise-oriented middleware. It's secure, scalable, and globally distributed, where you have a topic and multiple subscriptions that can collect data for you. So far, these devices send approximately 4 million messages per day, which is kind of a lot, just to give you an idea about the scale that PubSub can handle. Once this data comes into PubSub, you can see that you can have different mechanisms to start playing with the data, do some batch and stream processing on it. And this is where we use Dataflow, because it gives you a unified batch and processing service. It relies on Apache Beam, which is an open source programming model. So you write your logic once, and then you can pick whatever running environment you would like. So it can be Spark, or it can be as well Dataflow. The cool thing about Dataflow, it's fully managed. You don't need to scale it, and so it's hustle-free. And of course, it's very scalable, that supports millions of queries per second. So Dataflow is grabbing the data from PubSub and then doing the processing on it and putting it in Bigtable, which is a fully managed NoSQL database for you that can handle up to petabytes of data sets. And it's ideal for Internet of Things data like the time series. Currently, we store around 500 gigabytes of data coming from our buildings. And as I mentioned, we have only 100 buildings onboarded today. And then my favorite is Dialogflow. Dialogflow allows you to build chatbots or interactive agents that rely on really the knowledge of Google when it comes to the machine learning expertise related to NLU. It supports multiple channels. You can do chat, you can do voice, whatever channel you think about, you can integrate it. And it's one of the most widely used tools to build actions on top of the Google Assistant. So I will go through the demo a little bit. Oh, I can't point? Yeah, I can. So as you can see here, we have a user, which can be one of these three personas. It can be the landlord, the occupant, or even the facility maintenance operator that will interact with the chat application that will hit the facilities bot, which will interact with Dialogflow to interpret whatever the user input was. And then the facilities bot will actually handle the call with the APIs. So created a little video demo. Of course, this is just a proof of concept to show what is possible, but you can stretch your mind to support any type of operation based on the data that we have in our buildings. Yeah, I just wanted to make it high quality. Thanks. So what you will see here is the user is just typing queries to count floors on a certain building. So the beauty of that is that once we put this in place, we can change the building and tap to any building that Google is operating. So it can be in Cambridge, in New York. It will not change how we deal with this query. And this is thanks to the ontologies, but also the capacity of Dialogflow to interpret the query. You can search for meeting rooms information, such as I want to count how many meeting rooms do I have, or I want to just see them. I want to see the largest meeting room because maybe I'm hosting an event and I would like to know where should I book. I can change sites. And if I'm a maintenance operator, I would like to see it and understand where are these HVAC components. Because when you are a maintenance operator, usually you are walking into a building and all of these components are hidden for you behind the ceiling. So you don't see any pumps, you don't see any fans, you don't see any of these HVAC components. So you're like, okay, I need to find them, I need to locate them. And this is where the maintenance operator can use similar capabilities with a chatbot to understand where is the device, where is this equipment I need to go replace, where is it located. So here we're still targeting the floor level, but you can imagine we can show a map and guide the maintenance operator to go and look up where he needs to look to prepare the environment for him. So he can locate a fan because he needs to change this type of equipment. He can group them by floor because he would like to run some diagnostic operations on them and benchmark them by floor and how they are behaving. And here we can see more queries related to the HVAC. So these queries and the keywords that you are seeing, like the fans, the pumps, the fan coils, are all taken from brick schemas that we talked about earlier. Because brick allows to lay the foundation of this vocabulary. So we took these vocabularies and put them here. And of course, for some who don't want to type, we have also interactive menus where these queries can be already populated and the operator needs just to hit a button or click on one of them. So that's it for the demo. So of course, this was just a proof of concept to show what is possible on top of this building platform. I think I'm stuck on, okay, thanks. I think it's okay, there's just one slide. Thanks. So another example is also to extract time series and integrate them with a chatbot, or maybe integrate them in another third-party application. So that's it. I will pass the mic for Mark for the conclusion.
Thanks. Thanks, Theo. Well, I hope that gives you a little bit of an idea of what we've been building with this platform and what it can do. This really is sort of a work in progress for us for how we manage our own facilities at Google, but it really, is meant to show you some of the themes that have, been pervasive, I think, throughout the conference here. Particularly, we're doing this for ourselves on our own stack, right? And it's basically showing that you can build these kind of rich applications using a lot of the capabilities that Google already has. So, it's modernizing an infrastructure that frankly, hasn't been changed in many decades, right? So you're seeing a lot of new kind of analytics and applications and platforms sort of at the top level, but we're sort of going very deep into this stack all the way down to the device. You're seeing that we're using these building blocks in GCP as basically a way to build an application platform, right? So you're utilizing and not having to reinvent the wheel, as Charbel mentioned, for a lot of the capabilities in building out these applications. And we're also going from analytics to action. Right? So we're using capabilities like machine learning. We're using a lot of our data visualization and so forth to be able to take that raw data, which is sort of difficult to maybe discern messaging and action from, and do the analysis to be able to come up with a punch list for techs or operators to be able to go take care of. Whoop, went the wrong way. Our onboarding process really is, I think, leaps and bounds ahead of what it takes to do onboarding in typical systems today. And this is sort of where a lot of the intelligence is being developed right now. You know, as we go into new buildings and discover new types of devices, new kinds of network topologies, new kinds of gateway boxes and so forth, you know, that's helping to make this platform richer so that the next time we encounter it, it's much quicker to be able to onboard. It's really, you know, building out the fundamental intelligence of the underlying system so that it actually applies down the road as we go along. And we're using structured data here. So we're trying to use, you know, the best of what the industry is working on right now in terms of ontologies, in terms of terminologies, so that an operator will be able to take the you know, lessons that they learn in one building and be able to apply them into an entire campus or other buildings as well. So what next? Well, that's where you guys come in. We'd really like to continue the conversation, particularly if you have device data or interesting ways of representing data. So we touched mostly on things like climate control, HVAC today, but I mentioned that there's a lot of work that we're also doing for things like occupancy sensors and alarms and physical security and so forth. So if those are the kind of devices that you work with, we'd like to know how would that integrate with this platform? What would you be able to do if you didn't have to do all of that plumbing down at the bottom of the stack, but were able to just apply whatever it is that you do best at the top for applications. On device security and maintenance, you know, I touched on this a little bit at the beginning, but you know, we have been talking in the open source community about how to do continuous integrated testing of your devices to make sure that they're only communicating, you know, with the devices that they need to in the way that they're prescribed to. And that's something that we'll be talking a little bit about more publicly, but essentially this is something that we want to do at Google as well to be able to ensure that our network remains secure as well. And then again, the third-party apps and other integration, partner involvement and so forth, remaining involved with the various standards bodies and like, you know, ASHRAE, BRIC, Haystack and so forth. And if you have involvement there as well, we'd certainly like to hear you know, whether or not what you're doing sort of integrates well with what we're building with this stack so that we can make sure that when we encounter your devices out in the field, hopefully we will, that we would be able to integrate with them as well.
Aditya, answer your attendance. Aditya, ಕೇಳಿಸ್ತಾ ಇಲ್ಲ. ಆದಿತ್ಯ, ಅಜಯ್, ಅಂತಿಮ.
Sir, Amit, sir.
Sorry, Amit.
Present, sir.
1 minute, man. Ajay, Amit. Right. Antima.
Present, sir.
Purva. Ashwini. Bindu.
Yes, sir.
Divyesh. Gaurish. Gautami.
Present, sir.
Gunashekar.
Present, sir.
Harini. Surya. Naina. Nazma.
Present, sir.
Nidhi. Pradeep. ಪ್ರೀತಿ. ಯಾರು ಅದು ಗಲಾಟೆ ಮಾಡ್ತಾ ಇರೋದು? ಪ್ರೀತಿ.
Present, sir.
ರಾಜೇಶ್.
Present, sir.
ಸಹದೇವ್. ಸಾಕೇತ್. ಸಂತೋಷ್. ಸೀಮಾ. ಸಿಂಚನಾ.
Present, sir.
ಸ್ಫೂರ್ತಿ. ಶಶಾಂಕ್. ವರ್ಷಾ.
Present, sir.
ಯಶಸ್ವಿನಿ.
Present, sir.
ಅಮೃತ. One announcement is there. I will tell you, be on connectivity only. Amrita. Anusha.
Present, sir.
Apurva K.
Present, sir.
Sai Siddharth. Chetana. Kavya. Madhushri.
Present, sir.
Manish.
Sir, Manish is present, but his mic is not working, sir.
Then Sarfaraj.
Present, sir.
Murgesh.
Present, sir.
Mani. Paresh. Pooja.
Present, sir.
Prashant.
Present, sir.
One announcement is there. Be online. Pratibha. Bega. Pratibha. Pratik. Sadhana. Shashank. Shraddha.
Present, sir.
Sridhar. Tanoj. Tejaswini. Ani. Ashish.
Present, sir.
Vidya? 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 Vishal? Vishal? See, actually, whatever video you have seen, this and another one tomorrow, Delta Electronics, what I'm showing you, these two videos will be there as a case studies, and the same thing will be there for your third test also. Either one I will ask you as a case study, either Delta Electronics or either the Google, how they are dealing with an IoT based commercial buildings. So that will be there. So I may ask like this, you have to write in a Google, now they have told very clearly what are the softwares they are using to maintain the building and how the cloud is playing the role and how the ontology is working and all. So that things you have to write in a test, third test. So probably which will be there on 5th, 6th, 7th of January. So the case study question will be of this. Any doubts is there, you can ask me. Any doubts? Any doubts? Okay, now just I will stop the recording.
Sir, Chetana present.
Aitama.